to join so that they not miss the important. This is one of the most important concept. Okay, so if you don't understand FD, functional dependency, you will not understand closure. If you don't understand closure, you will not understand how to find a candidate key. If you don't understand how to find a candidate key, you do not understand the normal forms. Okay, so everything is linked here. Okay, so if you miss one lecture, everything is gone. Okay, so again you can watch the recording, but again there will be so much doubts here. Okay, so if you attend the session live here, there will be no doubts because you can ask it. Okay, but if you are watched the recording, I don't think that you will be able to get my point here. Okay, so that is why I'm saying that if your friends are not joining, just tell them to join this lecture because this is the most important lecture. Okay, so in DBMS uh, there are three important topics. Okay, first one is your ER, second one is your relational algebra, that is your SQL part. Okay, so that comes under different thing. But in the theoretical DBMS, there are two parts, that is normalization and ER. This is one of the most important part. Okay, so we have known about ER. From ER we are moving towards normalization. Okay, so I have already told you in the previous lecture why we need normalization, what are the advantages, disadvantages we face if we do not go with. Okay, so again, the PPT is already there. What is a functional dependency? How to do it? I'll give you simple examples to make you understand. Okay, so in simple words, the PPT and the formal definition are already there. Okay, so I'll give you simple definition so that you can understand. Okay, suppose there is a table that is given as ABC. In this table, there is something given like 1 A B, 2 A C, 3 B, something like this. Okay, so suppose there are 4 entries. Okay, so if you're seeing here, I'm saying that is A is functionally dependent upon B. Okay, so the symbol means functionally dependent. There is a simple property of a functional dependency that it's very simple. Okay, so understand this point, that if you're saying which is the attribute that is coming under review here, that is A and B. Okay, so if in a attribute, if in the entries of the attribute there is any particular entry repeated, okay, so there is any particular entry repeated here. Okay, so I'm only concerned with AB. Okay, I'm not concerned with C. I'm only concerned with AB now. So I'll just delete this part. Okay, so if in a table, when you are saying A is functionally dependent upon B, so what is the condition here? That if the tuple on the left hand side, that is A, repeats, if the tuple on the left hand side repeats, the right hand side of the tuple should also be repeated. Okay, as simple as that. If the tuple on the left hand side repeats, the right hand side should also be repeated. Now the left hand side is 1. This particular tuple is repeated here, that is 1. Now the right hand side is A here, the right hand side is A here. So it means that A is functionally dependent upon B. This condition is correct. A is functionally dependent upon B. This condition is correct. Okay. Similarly, if I say is B functionally dependent upon A, so check A and A is repeated here. You're seeing here A and A is repeated here. Okay. So if the left hand side is repeated, the right hand side also be repeated. A tends to 1 here. So again, if A is repeated, it has to tend to 1. But it is not tending to 1 here. A is not tending to 1. A is tending to 2. So it means B is not functionally dependent upon A. Okay. So if I tell you in simple words, very simple words, that if you are given with this relation, A is functionally dependent upon B, this holds true. This holds true if tuple of A, if you are facing tuple of A, T1 of A, if repeating, so I'm saying tuple 1 is repeating. So tuple 1 is equal to tuple 2 in A. Tuple 1 is this one, tuple 2 is this one. Tuple 1 is repeating, it means it is saying that tuple 1 is repeating. Okay, so it say that if the tuple 1 is repeated, then tuple 1 of BC should be equal to tuple 2 of BC. So if this condition holds, you can say that A is functionally dependent upon B, else A is not functionally dependent upon B. This is the simplest definition I can make. Okay. So do not care about the right hand side. Okay, so if there are elements repeated there, I do not need to worry about. Okay, so I give you simple example. Suppose this is a roll number, this is a name. It will make more sense. Okay, so I'm saying that 1 is Ram, 2 is Sham, 3 is Raman. Suppose there is another one, and again there is if if sorry, sorry 4 is also Ram. Okay, so if I'm saying, I can say roll number is functionally dependent upon name. Okay, so first of all, there is no repetition on the left hand side. If there is no repetition on the left hand side, you can directly say it is functional dependent. The functional dependence also always hold. Okay, so if you're seeing here, I'm saying Ram, one roll number is Ram, and again Ram is repeated here. So do not need to worry about that. You should not need to worry about that, because name can be same. And I'm not saying that I'm not asking name is functionally dependent upon roll number. Now check it. If I say that name is functionally dependent upon roll number, so Ram tends to 1. If Ram is repeated again, it has to be 1 here, but it is not. So you can say name is not functionally dependent. Okay, so it is like you are uniquely identifying a particular record. Okay, so if the left hand side, this one is unique, it will, the functional dependency will always hold. Okay, if this is not unique, you have to check it. Okay, you have to check it. Suppose if I'll say that if there is a Ram here and I will say the roll number is 1 here. Okay, so now check it, this particular functional dependency will again hold. Okay, so if the element on the left hand side, that is name, is repeated, the element on the right hand side should also be repeated, that is 1 and 1. Okay, similarly for roll number to name, it is again holding. Okay, so you get my point. Any doubt here, tell me. It's very important. If you don't understand it, just let me know. Okay, so I'll give you some examples so that you can understand this better. So some question is given like A is 10 to B, 1 1 2 1 2. Okay, so is this correct? A tends to B and B tends to A. Take your time and tell me which one of this particularly true. Answer it. Answer it. Anyone? Anyone?
So both are false.
What? Both are
It's a
false. Yeah. Yeah, absolutely correct. Both are false. Okay. So we are seeing here, uh, element is repeated here. Now, if the left hand side element is repeated, right hand side also be repeated, but they are different. Okay, so A is not 10 to B. Now check here, element is repeated here. If the left hand side is repeated, right hand side is also be repeated, but again it is different. Okay, so you can say again it is not functionally dependent. Okay, this is very easy. I'll give you one more question, so it's very easy also. So just answer in the chat box also, if you're comfortable with the chat box. I'll tell you how to answer it. I'll number it. So you have to tell me which of the particular functional dependency holds. Okay, so which is true. Okay, there are functional dependency written like A tends to B, B tends to C, B tends to A, C tends to B, C tends to A, and A tends to C. Okay, so these are 1, 2, 3, 4, 5, and 6. Okay, so just tell me which of the following functional dependency holds. Okay, so take your time. Tell me, anyone. Post it in your chat box if you're not, if you're comfortable with it. Yeah, absolutely correct. Okay. Again, I'm repeating the concept. If you are not understanding it, let me know. Okay. AB, check what is the limit repeated here. This is repeated. Okay. So the 1 tends to 1 and 1 tends to it is different. So you can directly say it is wrong. So B tends to C, which is the element repeated here. 1 and 1 is repeated. So 1 tends to 4. It has to be 4 here. It is 3. So you can say wrong. B tends to A, B tends to A, which is the element repeated. 1 and 1 is repeated. So again 1 is 1, 1 is 2. Again it has to be 1. So it is not wrong. Similarly, C tends to B, C tends to B. 4 and 4 is repeated. 4 is 1 and 4 is 2. They are different. So you can say wrong. C tends to A. C tends to A. 4 and 4 is repeated. Yeah, for both of them, 1 is there. No problem. 3, 3, 3 is repeated. For all of the entry is 2. That is again. There is no problem. So this is correct. Similarly, A tends to C. 2 and 2 is repeated. So the corresponding entry is also same. Okay, so that is correct. 2, 2, 2 is repeated and the corresponding entry is also same. That is also correct. Okay, so absolutely correct. 5 and 6 is the correct answer. Well done. Okay. So now see here, if I just extend this particular to 2 or 3 attributes. Okay, so how can you do that? Solve this question ABC 1, 2, 3, 4, 2, 3, 5, 3, 3. Okay, so tell me which functional dependency holds. Now I am adding one thing, that is BC tends to A. Okay, so this one, B tends to C and A tends to C. AC tends to A. Okay. 1, 2, 3, 4. Tell me which of the functional dependency holds. Okay, do it. Very easy. Okay, so I more people should also try to answer. Okay, three is the correct answer. Yeah. Any other one? Others should also answer. Why do okay. So now how to do this one is that E tends to B. E tends to B, there is nothing repeated here. So you can directly say it holds. Okay, so if there is nothing repeated here, it will not be different. Okay, so you may be thinking that 1 tends to 3, 4 tends to 3. This will not be functional dependent. No, this is not the case. You only have to check the left hand side. You do not need to care about the right hand side. Okay, so if the element in the left hand side is repeated, then you have to care about the right hand side. The element in the left hand side is not repeated. It's like roll number is determining name. So name can be repeated, but roll number should not be repeated. If roll number is repeated, the name should also be same. Okay, so that is the condition in the functional dependency. So A tends to be holds. This is correct. Okay, so again, anyway, if a particular element or attribute does not repeat, that becomes a key attribute. If there is a key attribute, you can directly say for key attribute any functional dependency hold. Okay, so A is a key attribute, you can say A tends to B and A tends to C. These are both are correct. Okay, now second one, BC tends to A. Now check, BC tends to A. 2 3 and 2 3 is repeated. Okay, 2 3 and 2 3 is repeated and corresponding to it should be 1. Both of the time it should be 1 or 4, but the elements are different here, so you can cross it. Similarly, B tends to C, 2 and 2 is repeated here, the element is same, that is fine. Okay, B and C holds. AC 1 3 4 3 5 3, this also holds because no element is repeated here. 1 3 4 3 and 5 3 are there, are completely different elements. Okay, so 1 3 tends to 2, 4 3 tends to 2, 5 3 tends to 3. There is no problem in that. Okay, any doubt here till now? Tell me. If you're not comfortable in speaking, just write in your chat box. I'll
Last
read it. Yes, yes, please.
AC to B.
What?
Last one, fourth one.
Last, you're not understanding question. This is not understandable. I'll repeat it. What you say?
Yes, sir, last one.
Okay, so I'll repeat it. Okay. So understand this point. The condition for functional independence is that you have to check the repetition in the left hand side. You have to check the repetition in the left hand side. Okay. So if there is any element repeated here, the repeated element should also be the same element repeated. Okay, suppose if there is one that is saying a here, if this one is repeated here, it has to say a. Okay, so if it is saying b here, this is wrong. Okay? Simple condition. Now if you check, a tends to b, there is no element repeated here. If there is no element repeated, it means that it is unique, so this particular functionality will always hold. Okay, so 1 tends to 2, 4 tends to 2, 5 tends to 3. I do not need to worry about. If the left hand side element is not repeating, you can directly say it is functionally dependent because this condition is always true. Now check, BC tends to A. Now what is BC here? BC is 2 3 and 2 3. Okay, so 2 3 and 2 3 is repeating. You're seeing 2 3 combination of these two attributes, 2 3 and 2 3 is repeating. Okay, so if on the left hand side they are repeating, the element on the right hand side should also be repeated. Okay, but the element here is not repeating, it is 1 and 4. Okay, so that is wrong. So this is not functionally, BC is not functionally dependent upon A. Similarly, B tends to C. B tends to C is 2 2, so this is repeating, the element on the right hand side should also be repeated. So 2 tends to 3, 2 tends to 3, there is the same element, you can say this is correct. Similarly, AC. Now AC here, 1 tends to 3, 4, 3, 5, 3. Anything is not repeating here, so there is no problem. Okay, so this condition is only applicable if anything is repeating. If it is not repeating, the left hand side is not repeating, it means it's a key attribute. If it is a key attribute, the functional dependency will always hold. Okay, keep that in mind. So this always hold because A is a key attribute, and you are seeing here A is combined with any other attribute, it will be again a key attribute. Okay, so if a key attribute is combined with any other attribute, it will be a key attribute. Any other doubt till here? Again, tell me, I will repeat it again because it is very important. Any other doubt? Any other doubt? You let me know. I'll again repeat it because important concept. So I'll tell you one more question. I'll give you one more question. If you, I hope this clears your doubt. Any other doubt? So this is a gate question. This particular question comes in gate 2002. Okay. So very simple question. 1 1 1 1 1 0 2 3 2 2 3 2. Okay. So they are saying A tends to B, B tends to C. Okay. Tell me which of the following functional dependency hold. Tell me. One or two. Take your time.
The A tends to B is true,
Yeah,
but
absolutely.
huh,
B tends to C is not.
is not true.
Yeah, absolutely correct. Okay. So we are seeing here why it is true. So check on the left hand side, the element is repeated 1 and 1. So right hand side is also 1 and 1. So there is no problem. 2 and 2 is repeated. Right hand side is 3 and 3. So there is no problem. So it is correct. Now check for B and C. Element is repeated, but here it is not repeating. So you can directly say it is not functional. So if you're seeing here, gate question are very easy. Okay. So if you're seeing here, the concept is very easy. If you understand this concept, the question becomes so much easy. Okay. So I'll give you one more gate question. Okay. Uh, okay. I'll give you X Y Z. It's again a gate question. I do not remember the year, but check it. 143, 153. These are the options that are given. 4, 5, 6. 3, 2, 2. Okay, so the option that are given is xz tends to x. Is this holding? Which of the following functional dependency holds? Z tends to y tends to z. And one more, that is xz tends to y. Okay, so try to do this. Take your time. Tell me which particular functional dependency holds.
Sir, excuse me, sir.
Yes, yes, please.
Sir, I think all are true.
All are true. Have you
Yeah.
checked it? Okay, so I'll check one by one.
सर
Because
सेकंड इज ट्रू है, मतलब लाइक सेकंड वाला ट्रू है और सारे बाकी फॉल्स है मेरे हिसाब से.
सेकंड वाला ट्रू है, बाकी फॉल्स है. ओके, चेक कर लेते हैं एक एक करके. सो एक्स जेड. Okay, so x z 1 3 and 1 3. Okay, so the element that are repeating here is 1 3 and 1 3. Okay, check on the x part. Okay, 1 3 tends to 1. Okay, so you have to write it like this: 1 3 1 3 x z tends to x. 1 3 1 3 4 3. They are not repeating, so 4 3 3 2 I do not need to worry about. I only need to worry about this one. Okay, so 1 3 tends to 1 and 1 3. Yeah, that is correct. Okay, so this particular functional dependency holds. Any doubt here? Because the element that are repeated here is 1 3 and 1 3. Okay, so they are tending to the same element, that is x. X is 1 1. Okay, any doubt here, or I move ahead? Okay, just let me know if you're facing any doubt, because it's very important to understand. Now xy tends to z. If you're facing difficulty, always try to write the element which are repeating. Okay, xy 1 4 1 5 4 6. Every element is unique. If you're seeing here in xy 1 4 1 5, no element is repeating, you can directly say it is a functional dependent. Okay, so this is a easy way to check it. If you solve more and more question, you will be able to figure out the common parts. Okay, because of the practice that I have done, I've solved around hundreds of questions around FD. I can, that is why I'm able to tell you that if there is no element repeating, you can directly say it is functional dependent. Okay, so these things you will not find in books that I am telling you. Okay, so this
Sir,
particular,
yeah.
yes, yes,
Sir,
please.
third one is false and the rest four are true.
Okay, third one is false. Okay, so check.
Hmm.
Let me check it. 3 3. Yeah, I think that is correct. Okay, so 3 3 is there. There is 4 5. So third one is false. Absolutely correct. Okay, so check yz. Yz. I think there is no element repeated on the left hand side. You can directly say it is false. Okay, so if there is no element repeating, you directly say. Now check xz. Okay, so just to avoid any confusion, I'm writing like this: xz. Xz 1 3 1 3. Okay, so their element is repeated. 1 3 1 3, and the corresponding element is 4 and 5. That is wrong. I do not want that. Okay, yeah, this is wrong. This is not holding. Okay, so if you are in doubt, let me know, because if you're seeing here xz is 1 3 and 1 3. Okay, so it is tending to y, it is 4 and 5. Okay, so I have written it. Any doubt here, let me know. Okay, just keep that in mind. One point that I want to figure out: if LHS is unique or a key, FD always holds. Okay, so let me know if there is any doubt still. Okay, not understanding it, I will again repeat it. I will give you more questions, don't worry about that one. Okay, now moving on forward with the types of functional dependency. Okay, so I am giving you the types, because with the, if you understand the types here, you will be easily able to figure out uh, functional dependency holds or not. Okay, so there is also one way you can figure out. First type is referred to as trivial functional dependency. Okay, so this functional dependency always holds. Always hold. I'll tell you which one, how to do it. how to recognize it. Now non-trivial you have to check it, and semi non-trivial, this is rarely occurs, but still there is a type here. Okay, so in trivial dependency, first type is the element that is depending upon itself, like A tends to A, B tends to B. So this will be always true. Why? Because if you're seeing here, there is a column A 1 2 3 4 5 6 7 8. So A tends to A means you have to write 1 2 3 4 and 1 2 3 4. Okay, so they will always hold. If the element is repeated here, like 4 tends to 5, it will be 4 tends to 4 again, because A tends to A. Okay, so this is referred to as trivial functional dependency. They always hold true. Okay, so it means trivial functional dependency is when the element is depending upon itself. Okay, another functional dependency, other one is that the something like this one, AB tends to A. Okay, so if you're seeing here, the left hand side is the superset of the right hand side. So if this is true, then again this is referred to as trivial functional dependency. It will always hold true. Okay, so check it in the previous example. The left hand side is the superset of the right hand side. Okay, so again, because it is dependent upon its own element. Okay, so that is why it always hold. It's always hold. Keep in mind that the trivial functional dependency are of two types: when the attribute depends upon itself, and when the left hand side is the superset of the right hand side. Okay, so these functional dependency always hold. Okay, so non-trivial dependency, we have to check it. We always have to check it. The most of the time we have done the non-trivial part. Okay, so it means that x is intersection y is equal to 5. There is nothing common between them. Okay, so here if you're seeing here, there is common, a is common, b is common, a is common in this one. Non-trivial means that there should be not anything common between the left hand side and the right hand side. Okay? So if a tends to b, now if you're seeing here, this is, there is nothing common between the left hand side and right hand side. A tends to BC, there is nothing common between the left hand side and the right hand side. AB tends to CD, there is nothing common between the left hand side and the right hand side. Okay, you get my point? Simple, as simple as that. Now semi non-trivial rarely occurs, but still this is a type that follows, that have trivial and non-trivial both inside it. So the example will be somewhat uh, AB tends to BC. Okay, so you're seeing here, B and B element is repeated here like this. Some element is common here if you're seeing here, and another part is that if I'll say x tends to y is not equal to 5. Okay, so I can say semi non-trivial, you can say that x tends to x intersection y, x is this, y is this, should not be equal to 5. Okay, so it means that is something in common. Okay, but again it is not a subset. If you're seeing here, the left hand side is not the superset of the right hand side. Okay, but there is one element repeated. So this particular category, keep that in mind, it is not a subset. The right hand side is not a subset. Okay, so it kind of contains both of the things here. So that is why I've said that this is rarely occurs. So most of the time we will be dealing with trivial and non-trivial, so you can forget about it because this never occurs. Okay, so now one more important point that is coming here is to find the closure. Okay, now we are moving towards, you already understand what is a FD. Now FD will be given to you all of the times, and from the FD you have to find the candidate key. For finding candidate key you have to know the closure. Closure is denoted by a plus symbol. Okay, so there are two methods to solve, to find the candidate key. First method is by the help of inference rules. Second method is with the help of closure. Okay, so inference rule, I'll tell you about the inference rules, but we will not follow the inference rules because this is not a foolproof method. Okay, so most of the time we will be using the closure method because it is a foolproof method. You will always get the right candidate. it is a very complex method, and sometimes you will miss out some important parts here. So I will not follow it. I will only follow the closure method. After, if you understand the closure, I will also tell you a shortcut also. Okay. So this particular shortcut, if you are solving many questions, you will easily able to figure out what will be the shortcut. Okay. So these particular question will help you. Okay. So I'm just telling you what are the inference rules so that you understand what actually it is. Okay. So the inference rule is given in this PPT, already given here. So there are some examples of FD. So I've given you enough examples, you can easily figure it out. Okay. So now these are referred to as Armstrong axioms, and these are referred to as inference rules. Okay. First inference rule is reflexive rule. Okay. What it means is that again it is talking about the trivial part. Okay. So it is saying that if x is the superset of y, left hand side is the superset of y, then you can say that x tends to y holds. That is absolutely correct, because we have already seen it that suppose x contains ab and y contains only a. Okay, so if you're seeing here, x means left hand side is the superset of y. You can say that ab tends to a. You can directly say ab tends to a. This will always hold because this is a trivial functional dependency. Okay, so this is also referred to as a reflexive rule. Okay, so if x is a set of attributes and y is a set of a subset of x, then x holds a value of y. Okay, so x holds a value of y. You can say that. Okay, so it means AB tends to A, this functional dependency always hold. So this becomes your trivial functional dependency. Trivial always hold. Now, another part is your augmentation. What is the meaning of augmentation? Augmentation means that you're adding something. Okay, so it means that there is already a functional dependency that says that A tends to B. You can add any other attribute like C on both of the sides. So C tends to C, A tends to CB, it will again hold. Okay. So if A tends to B is already there, you can add any other attribute with it, both sides, it will again hold. So this is referred to as augmentation. Understand? Augmentation means that you're just adding the same attribute on both of the sides. Simple. Transitivity rule is very, very simple. If Ram, if my salary is equal to, if Ram's salary is equal to Sham's salary and Sham's salary is equal to Lakshman's salary, it means that Ram's salary is equal to Lakshman's salary. Okay, so it simply means that A tends to B and B tends to C. You can say A tends to C. If you can say Ram is stronger than Balram and Balram is stronger than Raman, then I can say Ram is stronger than Raman. Okay, so this is the transitivity rule. So again, if I'm saying A tends to B, B tends to C, I can also say A tends to C. Simple transitivity. You may already have seen. There is another thing called union rule. Union rule, you can combine it. Like if X tends to Y, X tends to Z, you can say X tends to Y, Z. Simply combine it. There is no problem with that. Pseudo transitivity means that it is following some transitivity, but there is a pseudo in it. What it means is that you're saying X tends to Y, and they, in terms of Y, there is any one element is also added. That is W. Okay, so WY tends to Z. Okay, so what will be the answer here? So you can say X, which is the element not there in the transitive, that is W. So you can say XW tends to Z. So this you can say very similar to transitivity. Okay, decomposition is very simple. If you can say that XY tends to decomposition is X tends to YZ. You can say decompose it. X tends to Y, X tends to Z. Okay. So these are all your inference rules. With the help of it, you can derive it. But we will follow another rule that is referred to as a closure. Okay. So now closure is very, very simple. Very simple. Okay. So if you do not understand the closure part, just stop me anywhere because it's very important. Okay, so we are not following the inferences rule, we will follow the closure rule. Closure rule is very simple. Okay, suppose you are given a relation in which there are A, B, C, D, E. There are five columns. The functional dependency that are given to you is A tends to B tends to D, C tends to DE, CD tends to AB. Okay, these are given. So now I am saying to find the closure of A. So it will be denoted by closure of A plus. Okay. So now, first of all, the first rule to find the closure, to write the element itself. Okay. So if you're finding the closure of A, write the element itself first. Okay. Finding the element closure of E, you write E in there first. Okay. So I'm writing A in there. Okay. So now check on the left hand side, check if there is any A here. Yeah, there is a A here. So what it is deriving? It is deriving B. You write B here. Okay. Again check that on the right hand side there is a B. Is this B exist in your set? Yeah, this exists in my set. Okay. So what this B is deriving? This is deriving D. So include this D in the set. Okay. So now check if C left hand side, C is in your set? No, C is not in my set. So I cannot derive DE. Leave it. Is CD in my set? D is in my set, but C is not in my set. So again, I cannot derive AB from here. You stop your set here. This is how you find out the closure. Okay. So again, if you don't understand it, I will find the closure of B plus. Okay. So now check. First include the element itself, that is B. Now check A is A is in the present in the set. No, A is not present in the set. So you cannot include B. B is already included here, so there is no problem. Now check B is in the set. Yes, B is in the set. So what is B deriving? B deriving D. You write that D here. Now check C is in the set. No, C is not in the set. CD in the set. D is in the set, but C is not in the set. So CD is not in the set. You can say. So you stop here. This is your closure of B. Similarly, if I find the closure of C, first include the C itself. Okay, I'm including C itself. Now check C is already present here. So check the left hand side. So C is present here in the set. What you can do? What is C deriving? C deriving DE. So write D, comma E in the set. Now check here again. CD present in the set. Yeah, CD is present in the set. So what is it driving? AB. It is driving AB. So you write AB here. Again check. Is A present in the set? Yeah, A is present in the set. So B is already written here. No need to include another B. Is B present in the set? Yeah, B is present in the set. So B is deriving D. So D is already included in the set. Do not need to write twice. Okay, because this is set, you cannot write the same element in the set twice. So these are all done. Okay, so if you're seeing here, C is able to derive all the attributes like A, B, C, D, E. You can call C a key attribute because it is able to derive everything. So key. I am not saying candidate key, but key. Now, if there is any doubt, so do one more. D plus. Include D here. Now check. Is there D on the right hand side? No, there is no D on the left hand side because it is present in the combination with C. So C is not in the set. Okay. So it means that you cannot derive any element. So you can directly say set is closed. Again, I'll give you another example, that is E plus. Now check, include E. Is there E present on the left hand side? No, E is not in the left hand side. So you cannot derive anything. You stop the set. Okay. So now try yourself. Tell me what will be CD. What is the closure of CD plus? First you include CD. Now tell me the answer here. Take your time. Tell me the answer.
Sir, AB.
Yes, yes, please.
AB, sir.
AB. Any other?
All, sir, all ABCD.
Yeah, all.
Yes.
Why it is? Because if you're seeing here, C is already deriving all the. So if C is repeated, C is already, if C is repeated here, so it will again derive all the things. Okay, check it. CD. So C is deriving DE. You can write D already there. E again. Check it. There is no A. So CD is there. Yeah, CD is there. You can say AB. So you can include AB here. So if you're seeing here, everything is derived. You can check A. A is there. So B is already written. B is in the set. D is already written. So I think you get my point. Okay. So similarly, tell me what will be. Sorry. Just Tell me what is AD plus. Tell me what is it.
The closure of AD will be
ABD.
A, B, and B.
A, D, and B. Yeah, absolutely correct. Absolutely correct. Okay, now check. First you include ADB. Now A is there, B will always include B. First you include, sorry, first you include AD, and then you will check A is present in the set, so you will include B. Now B is present in the set, the D is already included, C is present, no, C is not present, CD is also not present, so you stop it here. Okay. So one more closure, tell me ABD plus. Okay, so after that I will give you a gate question.
ABD ही आएगा सर.
ABD?
Yes, sir. ABD.
Yeah,
Yeah.
absolutely. So first you include ABD. Now check A tends to B. Yeah. B tends to D. C is not in the set. CD is not in the set. So just close it. So it is the closure property is very easy to find. Okay. So now this is a gate question. So gate 2006. I think you can easily solve it if you understand this. Okay. So you are given a relationship A, B, C, D, E, F, G. Okay. So these are the attributes that are given. The functional dependency are AB tends to CD, AF tends to D, DE tends to F, C tends to G, F tends to E, and G tends to A. Okay? So they are asking about CF plus. What is the closure of CF plus? BG plus, AF plus, and then AB plus. Okay, so tell me first. Tell me the answer of CF plus first. Take your time. No need to quickly solve it. Just take your time. Mind it, it's a gate question.
Sir, BG plus, comma AC plus.
Tell me again, CF again.
BG
Then
So I
plus.
think the closure. Yeah.
CFDG.
CFGEAD.
Yes, sir.
AD,
CFGEAD.
CFGD,
EE.
GE. Okay,
EE.
CFGEAD. Yeah, absolutely correct. Okay,
Yes,
so
sir.
again, I think you get the point. Yeah, absolutely, this is correct. Okay, so also tell me the answer of BG plus. So I already know BG is there.
Sir, BGCAD.
BGEAD.
Sir,
Everyone
CAD,
is
not EAD.
BG.
Yes, sir. I
Everyone
guess.
is getting this.
So I think it will only be BGA.
BG E is not there. You're saying?
Yeah.
Okay. So BGAD. Everyone is getting it.
Not even D. So only BGA.
BGA. Okay. So BGA. Not even D. Okay. So let me check it. Any other get the different answer? Let me know.
Sir, BGCAD.
BGCAD. Okay. Yeah. Any other one want to try? Okay. So again, follow the same approach. First include BG.
EGCAD.
Okay, so check any other element repeated here. G is there, so you can include A. Okay, so check any other element that you can be repeated. AB, yeah, AB is there, so you can include CD. Yeah, if you're seeing here, AB is in the set, you can include CD. AF is not in the set. D is in the set. DE is not in the set. C is in the set, so G is included. F is not in the set. G is in the set. A is already there, so this will be the answer. So this one is correct. Okay, whoever said this one, it is correct. Any doubt, let me know. Okay, so go solve it. AF plus. Okay, so do not just quickly solve it. Take your time. Okay, so
Sir, AFED.
AFED.
Yes.
Okay, everybody got this one or anyone different?
Sir, AFEGD.
AFEG. Yeah. Anyone got a different answer?
Sir, AFEGD. D उसमें E.
Okay, DG.
Sir, AFEGD.
Okay, AFEG.
सर चैट देख लीजिए सर.
A for apple, like that. Repeat.
सर चैट.
This is
A
correct.
F D G E
AFEG or
and D.
DG. D for dog or E for Eon?
Elephant.
E for elephant. Okay, so AFEG. Yeah. Okay. So again, let me check. So first include AF in the set. Now check F. So we will get F. You will get E. Okay. So any element that will be repeated there, AB is not in the set. AF is in the set. Okay. So you will get D. DE in the set. D is also in the set. So you can write F. F is already included. C is in the set. No. F is in the set. Yes. E is already included. G is in the set. No. G is not in the set. But A is already included. So this will be the answer. Okay. Any doubt? Let me know. The last question will be AB plus. Okay, anyone?
Sir,
Sir,
A,
I think
B, C, D, G.
A, B,
yeah,
C, D,
A,
G. Yeah,
G.
absolutely correct. Okay. So I think most of you got the concept. If you want more question, you can refer to this PPT. Okay. I think closure and candidate key they are given together. But don't worry about the candidate key concept right now. You just worry about the closure part. Okay. So you can see for your example the closure properties here. Okay. So I'll tell you one by one how to find the candidate key. It's very easy. I'll tell you in the next one. Okay. So any doubt, let me know, and I'll see you in the next one. Again, I'm repeating. If any doubt, let me know because it is very